Welcome to the Unit 6, Section 2 video on solving by graphing. All solutions of a linear equation are on its graph. To find a solution of a system of linear equations, you need a point that each line has in common. In other words, you need their point of intersection. So if I were to graph this system of equations, you would have two lines on the same graph. They have different slopes, so they will have two lines going two different directions, and they will intersect at one point. And the point in which they intersect, 2, 3, is the solution to not only both equations, but also to the system. A system of two linear equations can have no solution, one solution, or infinitely many solutions. Again, no solutions are a result of parallel lines, same slope, different y-intercept. One solution is intersecting lines, which means you have different slopes. And infinitely many solutions occurs when you have the same line, which means you'd have the same slope and the same y-intercept, so both equations are essentially going to be the same. So, example 1. Graph the equations y equals x minus 4 and x plus 1/2 y equals 5/2 to find the solution of the system. So we're going to rewrite the second equation in slope-intercept form. Y equals negative 2x plus 5. And then you're going to graph both equations. Okay? Once you graph both lines, you find the point at which they intersect, which in this case is the point 3, negative 1. And because we have different slopes, that means we have one solution, and the solution is the point 3, negative 1. And you can run a check of this by plugging 3, negative 1 into both the first equation to find we have a true statement, and the second equation to again find that we have a true statement. And in this case, I plugged it into my y-intercept or my slope-intercept form. In this next example, we're going to graph these equations and determine what our solution set is going to be. So we're going to write the equations in slope-intercept form by subtracting x on both of those. And we have the same slope, but different y-intercepts. So this tells us we should have parallel lines, which when we graph it, we do. And parallel lines mean that the lines will never touch, meaning that there is no solution. And then in this example, we're going to determine the number of solutions. We're going to rewrite the equations in slope-intercept form, which by now you know how to do, so there's your rewrites for you. We're going to graph the two equations, and since they are essentially the same equation, you're going to have the same line, which means the lines are on top of each other, and we have infinitely many solutions. Thanks for checking out my video in the Foundations in Algebra series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.